Alrighty, we're going to go through 19 through 28 in June 2017. So for this one here, we want to get a common denominator. So factor out all of the denominators. This is the idea that when siblings get gifts, we want them all to have the same gifts so they're not jealous. So in that last denominator, you can pull out an x, you're left with x minus 2. In getting your common denominator, first one's going to have to get multiplied by x, middle one by x minus 2, and the last one already has everything. So we'll have 2x times x, which will give us 2x squared. We'll have the minus 11 times x minus 2 equals 8. Now a common error here is people forget to distribute the negative through the parentheses. So we've got to distribute a negative 11, not just an 11. So that's going to give us 2x squared minus 11x plus 22 equals 8. We'll subtract the 8 from both sides. That's 2x squared minus 11x plus 14 is equal to 0. Now, not everything divides by 2, so you can either do this with quadratic formula, or you can do your a times c method. We'll show you both ways. So first off, if you do the a times c method, 2, which is the a value, times 14 will give you 28. That becomes what you want to multiply to, and the negative 11 is what you want to add to. So that would be a negative 14. Nope, take that back. That would be a negative 7 and a negative 4. And if you're unsure of that, do 28 divided by x in a graphs page, do Control T, and then you're finding a pair of things that add to negative 11. So I'm going to write this as 2x squared. It's your choice if you want to do the negative 7 or negative 4 first. But we're going to have negative 7x minus 4x plus 14 equals 0. We're going to split it down the middle using our flower box technique. We can pull an x out of the first thing, leaving us with 2x minus 7. So then we automatically want to have 2x minus 7 in the second one. A negative 2 would have to go out front to make that work. So we'd have x minus 2 and 2x minus 7. That's going to be equal to 0. Set those each equal to 0. If we add the 2 over, we'll get x equals 2. If we add the 7 over, we get 2x equals 7, and divide by 2 to get x equals 7/2. Now you could have also done that with quadratic formula, with the a value being 2, the b value being negative 11, and the c being 14. And you would have eventually got the 2 and the 7/2 as well. So you always have to check your solutions with fractional equations, and we're checking to make sure the denominator is not 0 for any of them. Well, when we check the 2, 2 minus 2 is 0. So we would have to reject that. And that is what is called an extraneous solution. The 7/2, when you sub it into the denominators, would check out. So 7/2 is a solution. 2 is an extraneous solution, meaning it comes up algebraically but does not check out. So we would have choice 1 in this case. Moving over to 20. So there's a couple ways we can do this. We know f of 9 is equal to negative 2. So that means when n equals 9, we should get back a negative 2. Also, negative 8 would be n equals 1, n equals 2 would be negative 7.25, n equals 3 is negative 6.5, and n equals 4 is equal to negative 5.75. So we can do any of these n's to start eliminating choices. So I'm going to do n equals 1. We want to get back negative 8. But if you sub in 1 for n in the first one, you're going to get back negative 7.25. We can rule that one out. If you sub 1 in for n into the second one, you're going to get negative 8. So we'll keep that in the running. If you sub 1 in for n in the third one, you're going to get negative 8. We'll keep that in the running. And if you sub in 1 in the fourth one, you're going to get positive 7.25, so that one's ruled out. Well, now let's move on to n equals 2. n equals 2, we're hoping to get back negative 7.25. When you sub in 2 to the second choice, you'll get negative 8.75, so that's ruled out. 2 into the third choice will give us negative 7.25, so that's our one that we want. I chose n equals 1 and n equals 2. You could do any few of those to narrow it down to which one's correct. Now, if you were going to do this one directly with your arithmetic sequence formula, instead of fn or an, they just have f of n. Off our reference sheet, it's a1 plus in parentheses n minus 1 times d. So we would have our a1 is negative 8. We're adding 0.75 each time, so we'd have plus n minus 1 times 0.75. So we would want to notice that that does not match choices 2 and 4, which are in that form. And then you would distribute the 0.75 and combine like terms to see that it would end up eventually being choice 3. In 21, we had average rate of change. Make sure your calculator's in radian mode because we have trig with the sign. Our interval is negative 7 to 7. You're never going to have to guess which x values to use. So put this in a graphs page, do a control T, get what your negative 7 is, or you could have put the negative 7 in for x just in the equation on a calculator page, your choice. Keep this out all the way. So we got 3.36 dot 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 dot, keep it out all the way. For 7, we should have gotten negative 0.29 dot 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 dot, keep it out all the way. And then we're just going to do our y2 minus y1 over x2 minus x1. So I'm going to start with the 3.36 dot 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 dot. Again, I'm keeping it out all the way in the calculator, minus a negative 0.29 dot 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 over negative 7 minus 7. And once you put that in, you'll get minus 2.6, or sorry, minus 0.26 and change. So that ends up as choice 3. All right, going to the next one. We want to model the cost per year over a lifetime. Well, per means divide, so we should have a cost amount divided by the number of years. Well, they tell us that the number of years is n. So we want one of the ones where we're dividing by n. So that's got to be choice 3 or 4. Now the tricky thing here is they try to confuse you with the 3 months. So they run it 3 months out of the year, and that's your cost for the whole year, the annual operating cost. So that already includes all 3 months. So that's why it's going to lead us to be choice 3. They wanted you to think, oh, 3 months, I've got to multiply that 108 number by 3 to get the 326.34, but that's 3 months is already tied into the 108.78. 23 rewritten is another way of saying equivalent. If you just rewrite something, it doesn't change the value of it. It just changes what it looks like. So this could be done with a store. Store a random number for x, type it in, type in the 4 choices, and you'll find that number 4 is the one that matches. And the last one here, we're compounded monthly, so we want to be thinking the formula a equals p times 1 plus r over n raised to the nt. We should have that written on our packet somewhere, along with a couple other things like the independence formula and the continuously formula. You'll want to make sure you study those before the test because you could see them on there. So I'm going to keep writing it as A even though they have S. It's the same idea. So we're starting with 100. So we have 100 parentheses 1 plus 3% as a decimal is 0.03. Compounded monthly, so we're over 12. We're raised to the 12 for n. And we want to know after 1 year, so we're putting in 1 there. So we're going to have 100. We'll have something raised to the 12. When you put the 1 plus 0.03 over 12 in, you end up getting the 1.0025 in the parentheses. So that matches with choice 3. For number 25, R of 2 means to sub in 2 for x. You need to show some work when you're doing that, or at minimum say R of 2 equals, and you eventually get back 6 for that. What that 6 represents is the remainder. So in the second part, x minus 2 is not a factor because the remainder was not 0. 26, draw our little curve. 8.25, we want less than it, so shade to the left. This is a norm CDF. Because we go forever to the left, we would want negative 5 nines, then the 8.25 for our upper bound. Then it's always alphabetical order for those last two, mean and then standard deviation. So we would have 8 and then 0.5. And to get to the norm CDF on the calculator, you're doing menu, probability, distributions, and then norm CDF. We wanted our percentage to the nearest integer, so move your decimal over twice to first get a percent, and then the tenth spot is a 1, so that keeps the percent as 69%. For 27, we got 4 things, so we're doing flower box method. Split it down the middle, you can take out an x squared, leaves you with 4x minus 1. So we automatically want 4x minus 1 in the other parenthesis. Think what times 4x gives you 16x, that would be a positive 4 out front. So our stuff in front is x squared plus 4, and then we have 4x minus 1. Now x squared plus 4 does not factor anymore. If it was x squared minus 4, it would factor into x plus 2, x minus 2. But x squared plus 4 does not factor. This is as far as we can go. You should not be setting these equal to 0 and solving because there was no equal sign in the original problem. If it just says factor, you're just doing your parentheses. If it said to solve, you would have had an equal 0, and then you could solve for the values of x. And then the last one that you had to do for the homework, number 28, period is the length of a full cycle. So go from the maximum to the maximum, and notice along the x-axis that is 2/3 of a second. And what this represents is it's just the length of time for the wheel to go around once, because the period represents a full cycle, and in our problem here, a full cycle is the wheel rotating once. For the rest of the period, you're going to be working on 29 through 37 in this packet. Anything that you don't finish in class is your homework. Have a great rest of your day.